Welcome to True Projects. In this video, we are going to explain about the project entitled as Document Re-ranking with Evidential Neural Networks. So before getting into the video, let me give you the brief description about the project. The project refers to improving the order of retrieved documents by using neural networks that model not only relevance but also uncertainty. Evidential neural networks provide confidence aware predictions by presenting evidence for relevance rather than fixed probabilities. Coming to the abstract explains that in question answering systems, accurately ranking documents is essential for selecting the best possible answer to a user's query. Modern approaches like retrieval augmented generation dependent heavily on a re-ranking stage where the most relevant context passages are chosen. However, traditional deep neural network based re-rankers often produce poorly calibrated probability scores, meaning the model is overconfidential even when its predictions are incorrect. This overconfident results in unreliable document rankings and reduces the overall effectiveness of the QA systems. To overcome these limitations, the proposed evidential document re-ranking model incorporates evidential deep learning to exploit model uncertainty by learning a fully probability distribution rather than a single confidence score. By estimating how certain or uncertain a prediction is, EDRR improves probability calibration and ranking reliability. Additionally, the model uses an active learning strategy that focuses retraining on uncertain samples, which further enhances accuracy and reduces uncertainty. Experimental results on well known datasets such as natural questions, MSMARCO, and Hotpot QA shows that EDRR achieves better performance than existing models, demonstrating its effectiveness as a robust and trustworthy re-ranking solutions for QA systems. Coming to the existing system, the existing document re ranking systems used in question answering applications are mainly based on deep neural network models such as cross encoder, Colbert, and dense passage retrieval. These systems works by assessing relevant score to candidate documents using prediction probabilities produced by classification models. Although they perform well in retrieval relevant documents, their training process focuses primarily on minimizing prediction losses, which often results in poorly calibrated probability estimates. This means the models become overconfident, sometimes assessing high relevance scores to incorrect or less relevant documents. Additionally, these existing systems do not exploit estimate or model uncertainty, making it difficult to identify unreliable predictions. As a result, the re ranking process becomes less dependable, especially in complex QA scenarios where multiple documents have similar relevance, ultimately affecting the overall accuracy and reliability in QA systems. Coming to the proposed system or base paper work, the proposed system introduced the evidential document re-ranking model to overcome the limitations of existing QA re-ranking approaches. Unlike convolutional deep neural network models, EDRR integrates evidential deep learning to explicitly model uncertainty by learning a fully posterior distribution over relevance probabilities instead of relying on a single confidence score. The system operates in three main stages: initially training a birth based encoder on a subset of the data, followed by an active learning phase where documents with high uncertainty are iteratively selected and added to a training set. And finally, applying the trained model to re rank documents in the test set using both relevance score and uncertainty estimates. By qualifying uncertainty, the model reduces overconfidence and improves probability calibration, leading to more reliable ranking decisions. This uncertainty aware ranking strategy enhances the robustness and accuracy of the re ranking process, particularly in complex QA scenarios where distinguish between similar relevant documents is challenging. Coming to the dataset, the Natural Questions dataset is a widely used benchmark dataset for questioning, answering, and information retrieval research. It is composed of real, anonymized users' queries collected from the Google search engine, and it is paired with relevant passages extracted from Wikipedia articles. Each data record typically includes a natural language question along with one or more contextual text passages in which the answer may appear. The dataset is designed to reflect real world QA challenges requiring models to understand and process long and complex documents rather than short, isolated paragraphs. Originally released by Google Search, the dataset contains large scale annotations, including long answers that identify relevant sections of text and short answers that provide precise response spans. Due to its realistic structure and complexity, the Natural Questions dataset is extensively used for training and evaluating QA systems. Document retrieval models and retrieval augmented generation frameworks, making it highly suitable for testing advanced re ranking approaches. Coming to the novelty or extinction or enhancement or improvement. As an extension to the proposed evidential document re ranking framework, the base birth model is replaced with a more advanced and computationally effective transformer architecture, Robot A. Although Birth provides strong baseline performance, it is relatively heavy and less optimized compared to new models. Robot A improves upon Birth through enhanced training strategies, better contextual representation, and improved prediction accuracy while maintaining greater efficiency. Integrating Robot A into the EDRR framework enhances document ranking performance and provides more accurate uncertainty estimation, leading to more reliable re ranking results. Additionally, since large language models require substantial computational resources such as GPUs, which are not always freely available, the implementation emphasized reducing dependency on heavy pre-trained models. This makes both original EDRR with Birth and extended EDRR with Robot A more practically and suitably for resource constrained environments. In addition to the model level extension, a Flask based web interface is developed to improve usability and accessibility of the system. The Flask framework allows the users to interact with the trained EDRR models through a simple and intuitive user interface, where users can input queries and obtain relevant predictions without direct interacting with the backend code. This UI integration bridges a gap between model development and real world application, making a system easier to test, demonstrate, and deploy. The Flask based interface enhances the overall system by providing a practical, user friendly platform for prediction and evaluation. Coming to the flow of the work, first we have environment setup and library import. The notebook begins by importing essential Python libraries and suppressing unnecessary warnings to ensure a clean execution environment. Core libraries related to data processing, numerical computation, machine learning, deep learning, and visualizations are loaded. The step prepares the environment for executing birth based and evidential learning models. Next, loading pre-trained language models. In this step, pre-trained transformer models are loaded. Initially, the birth model is used as a base encoder for document representation and relevance prediction. Later, an extended version using the Robot A model is also defined to improve efficiency and accuracy. These models form the backbone of the evidential document re-ranking framework. Next, text processing and NLP utilities. Text processing and NLP utilities. Custom NLP pre-processing classes and functions are defined to clean the input text. This includes removing stop words, special characters, punctuations, and relevant symbols for questioning and documents. The clean text ensures better contextual embeddings and improves downstream ranking performance. Next, dataset loading and exploration. The Wikipedia Natural Questions dataset is loaded and displayed for inspection. This dataset consists of question document pairs with relevance labels serving as a primary benchmark for training and evaluating the document re-ranking models. Next, feature extraction using BERT. The clean dataset is passed through the pre-trained BERT encoder to generate contextual embeddings. These embeddings represent systematic relationship between questions and documents and are used as input features for relevance classification and uncertainty estimation. Next, initialization of evaluation metrics. Global variables are defined to store evaluation metrics such as accuracy, precision, recall, and F score. These metrics are later used to compare the performance of the proposed EDRR model with existing baseline algorithms. Next, model evaluation function definition. A dedicated evaluation function is implemented to computate performance metrics for different algorithms. This function takes ground truth labels and predict outputs as inputs in calculate accuracy, precision, recall, and F score, ensuring consistent relevance across all models. Next, dataset shuffling and base sample selection. The dataset is randomly shuffled to avoid bias. From the shuffled dataset, an initial subset is selected as a base training data aligning with the first phase of EDRR framework. Next, uncertainty score computation. A function is defined to calculate uncertainty scores using evidential outputs. These scores qualify the confidence of prediction, enabling the model to identify uncertain samples that require further learning. Next, evidential learning with BERT. An evidential learning function using the BERT encoder is implemented. This function trains the model to predict relevance while also learning a full Portia distribution over class probabilities. The model outputs both relevance scores and uncertainty estimations, addressing the overconfidence issue of convolutional DNN classifiers. Next, evidential learning with robot A. As an extension, a separate training function is implemented using the robot A model. This step replaces BERT with a more advanced, efficient transformer architecture to enhance prediction accuracy while reducing computational overhead. Next, active learning integration. During training, samples with high uncertainty are iteratively selected and added to the training set. The model is retrained with these informative samples, gradually reducing uncertainty and improving overall ranking performance. Next, evidence and uncertainty aggregation. The evidential outputs are converted into structured arrays to aggregate evidence, belief mass, and uncertainty values. These aggregated values are later used in the re ranking and evaluation stages. Next, performance visualization. The performance of all algorithms, including baseline models and the proposed EDRR variants, is organized into tabular form. This allows for easy comparison of metrics across different approaches. Next, final results display. The final evaluation metrics accuracy, precision, recall, and F score are displayed for each algorithm. These results demonstrate that the proposed EDRR model, particularly with Robot A, achieves superior performance compared to existing re ranking approaches. Coming to the front end, a front end of the system is developed using a Flask framework and includes user registration and logging functionality supported by an SQLite database. Users can provide input queries to the interface, which are pre processed and passed to the trained model of prediction. The final prediction results are displayed to the user through the front end. Coming to the requirements, we have both hardware requirements and software requirements. Hardware requirements consisting of operating systems Windows only, processor i5 and above, RAM 8 GB and above, hard disk 25 GB and above. Software requirements consist of application framework Python 3.7.2, front-end framework is Flask, back-end framework is Python IDLE, database is MySQL, front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. To execute this project, first we need to open the code folder which contains the project source code files. This folder is a complete package of your project's code base containing everything needed to develop, test, and deploy your application or model. Static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap. Templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represents different pages of the website. App.py file. This .py file contains the information related to front-end logic. It could include code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. Model file. These are the model files which contain the algorithm information which will be loaded into the project code during the runtime. IPYNB file. This is a Jupyter Notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute the code in individual cells, making it a popular choice for data science. Signup.db file. This file is a database file used to store the user information. Now, coming to the execution of the project, firstly, you need to copy the path of the code folder from the address bar of the file explorer. Then open command prompt. Using the command cd followed by a space and then paste the copied path. This command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py in the command prompt. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address with the port number of 5000. Copy the local link provided by the framework and paste it in any web browser. I prefer Chrome. This is a homepage of the project should now be displayed in the browser. This is a front end built using Flask framework. In this page, we have home button, login button and register button. Firstly, click on register button so that the sign up form will be open where you need to enter the details and create an account for user authentication like username, full name, mail ID, mobile number and a strong password. Then click on sign up so that all the given details are stored in signup.db and login.html will be opened where you need to access the application by entering the username and password. Then click on login so that the prediction page has been displayed. In this page, we have prediction button, graphs button, notebook button, and logout button. Firstly, click on prediction button so that the EDRR based question answering form will be open where you need to enter the question and predict the output. Firstly, let us enter the question and then click on predict so that the input is pre-processed and the output will be displayed as the input text and the predicted result. Next, click on graphs button so that the graphical representation of the project will be opened. So let us check one by one. Firstly, we have accuracy comparison graph. The graph compares the accuracy of two models, proposed EDRR with birth and extinction EDRR with robot A. The extinction EDRR with robot A achieves higher accuracy around 0.87% than the birth-based version around 0.77%, indicating that robot A improves model performance. Next, we have precision comparison graph. The bar chart compares the precision of two models, proposed EDRR with birth and extinction EDRR with robot A. The extinction EDRR with robot A achieves higher precision of 0.44% than the birth-based model is of 0.38%, indicating it performs better at correctly identifying relevant items. Next, recall comparison graph. The bar graph compares the recall performance of two models, proposed EDRR with birth and extinction EDRR with robot A. Both models achieve the same recall of 0.5%, indicating they are equally effective at identifying relevant items. And next we have F-score graph. The bar chart compares the F-score of two models, proposed EDRR with birth and extinction EDRR with robot A. The model using robot performance slightly better achieves a higher FN score of 0.47% compared to the birth based model of 0.43%, indicating a modest improvement in prediction accuracy. Then click on Logout. Finally, this project demonstrates that document re-ranking using evidential neural networks enhances both the accuracy and reliability of information retrieval systems by incorporating uncertainty awareness into relevance predictions. The approach produces more robust rankings, especially for ambitious or complex queries, making it well suitable for real-world search applications. This is all about your project. Thank you.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.